what you're thinking. This is quite cool music, and it's not annoying at all, right? Fortunately, it's not music. But if it's not music, then why all the noise? Well, if you've ever been in an MRI, then you probably remember the very loud noises. And if you've never been in an MRI, well, this was just for you. In real life, though, it's much more loud. The volume can go up to 120 decibels, which is about the loudness of a plane that's starting. People describe it as thumping or hammering or ticking, but whatever you describe the noise with, the question remains, what is all the noise about? And to answer that question, we first need to understand what is an MRI. And MRI stands for magnetic resonance imaging. And simplified, those three words stand for three different components that help to create the image. So let's look at them. Magnetic. The MRI uses the fact that hydrogen is very common in the human body because we're made up about 70% of water. The hydrogen's nucleus is one single proton that is spinning around its own axis like the Earth's rotation. And just like the Earth, the proton has a north and a south pole, so it's like a tiny magnet. Now, so it's like a tiny magnet, exactly. And these rotational axes of the protons, they are usually very randomly directed in space. But in a magnetic field, like in an MRI, they all start to line up. Resonance. Now, after aligning all of the protons, they are flipped away from the main magnetic field by a burst of energy. That is a radio wave. And importantly, the frequency of that radio wave has to be the same as the frequency of the proton spin. They have to resonate with each other. After the flipping, the protons start to realign with the main magnetic field. And this happens at different speeds in different tissues. And this tissue-related relaxation time is what we use as signal. Now we only need to know where are we in space. And for that, we have three different magnets that have a temporal field that increases along the three spatial axes, x, y, and z, in magnetic strength. So each point in space has a specific magnetic strength that defines the location in space. And these magnets, they make the loud sound because they are continuously switched on and off. So in the future, if you're annoyed about MRI noises, maybe use this knowledge to choose to rather be amazed by that we are able to see into our bodies just because some tiny hydrogen atoms are quietly but continuously pirouetting through life.